Hi there, I'm Scott Lowe with ActualTech Media. Thank you for joining us for this Spotlight Series segment. Today we're joined by Dan Wendlandt, who is the CEO and co-founder of Isovalent. Dan, thank you for joining us today.
Hey, thanks for having me, Scott. I appreciate it.
So I did a little bit of research on Isovalent. You guys have an interesting security play. Can you tell us a little bit about what you do?
Sure. So most of our customers are adopting Kubernetes as the new platform for how they build and run their modern workloads. And what you'll find out if you start using Kubernetes is Kubernetes doesn't really care about all the traditional mechanisms you used to use to secure workloads. Things like VLANs and physical firewalls that use subnets. And so customers face these challenges of how do they meet those security requirements, isolating multi-tenant workloads, doing security incident investigations inside these kind of modern Kubernetes environments. And that's really where our technology comes into play.
And it looks like your technology, it's some kind of, it seems like low-level packet filtering, so it doesn't matter what the upper layer applications are. Is that accurate?
Yeah. And again, it's actually even more than just packet filtering, but it's built on a Linux kernel technology called eBPF, which, traditionally the Linux firewalling capability was very static. It was built on IPs and ports with technologies like IP tables or Open vSwitch. These are the technologies that I and my co-founder built, 10 plus years ago. And, the world has moved on from IPs and ports being kind of the reasonable way to think about security visibility and security enforcement. And Kubernetes takes that to an extreme. IPs are just meaningless inside of a Kubernetes environment. So the question is kind of how do you make Linux natively understand it's this Kubernetes service talking to this Kubernetes service and maybe even making this API call to this Kubernetes service. That's really the kind of power that's unlocked by us building on top of Linux eBPF.
And so what kind of capabilities are you able to bring to bear by using eBPF and supporting Kubernetes and container-based workloads?
Yeah, we tend to kind of divide our functionality into three buckets. We think about connect, observe, and secure. And so from a connectivity perspective, this could mean basic workload connectivity, but it also means things like load balancing. In a cloud native world, you don't never just have one replica of a service, you have multiple replicas of a service. Using eBPF gives you really high performance load balancing there. Security, I already mentioned two use cases, firewalling two workloads in these very highly dynamic environments. How do you know that service A can talk to service B, but not to service C, for example? And then observability, how do you troubleshoot these environments when two services can't talk to each other? eBPF really gives us kind of what I always like to describe as an unfair advantage in terms of being able to do really deep, powerful, high performance connectivity, observability, and security.
One of the realities of modern application environments is their dynamic nature. So not, as you said, like IP tables is no good anymore because nothing's static. But that also makes maintaining security systems and connectivity and making sure things can talk to each other really difficult sometimes. How does your solution help administer? Like, does it discover the network? Does it discover the services? How does it help administrators improve communication? And then by that token, but you can observe, you can secure, and improve security.
Yeah, no, I think that's a great point. I mean, in practice, the observability is actually kind of a foundation here, right? Connectivity, of course, you need, but you can't really implement good security until you know what the behavior of the application is in the first place. And as we said before, you can't just have that observability be based on ephemeral things like IP addresses. So really, I think the key thing to understand is networking is fundamentally about things like service identity now. It's if you think, I always like to think about if a developer were to draw their application on a whiteboard, how would they draw it? If your observability solution doesn't give you that same level of simplicity and clarity, you're going to have a horrible time trying to understand this dynamic, cloud native world where this service is making this API call to that service, et cetera. And that visibility is, as you mentioned, the foundation of, well, how do I even know what security policies to create? Well, I need to have that visibility to create the policies. Or how does my security team do an incident investigation or even establish a baseline? So yeah, I think one of the major changes here is that observability is just such a fundamental requirement in terms of how people are thinking about networking and connectivity in modern Kubernetes environments.
So if I deploy your solution in my environment, does it start life by observing the network and determining what calls are being made and building sort of a map that way? Or as an administrator, am I manually defining things so that basically I know what's talking to whatever and all that good stuff? But like, how are we capturing that snapshot of what things are supposed to look like and then maintaining it in what's in a dynamic environment? Is this something that, I assume the tool does that in some way, shape, or form?
Yeah, and actually that's one of the real powers of what we do. When you have visibility, the visibility has to be very lightweight so it can be always on. That's one of the things that eBPF helps us with a lot, right? IP tables are something where observability was designed as hey, just in case something reaches here, log it, right? Versus in a eBPF world, we can have the observability always on. So even that connection that happens only once every 24 hours, you still see it, right? Because the observability is always on. And so then the second thing is, because we're identity based, we can actually simulate the network policy behavior. So we can say, just capture all of the data for this environment. And then the security team can come in and say, hey, I would like to have a baseline policy that isolates every tenant, and that locks these things down this way. And then we can actually, independent of actually running the traffic, we can compute and do that logic to say, hey, that will result in this traffic being denied. Is this traffic you were intending to deny? Or, for example, should we be adding an exception for that network connectivity? And I think one of the interesting things is that used to be something the IT team does, but increasingly in Kubernetes environments, or the IT or the security team, increasingly we see that delegated to the actual application teams themselves. And having that workflow of creating the security policies and evolving them integrated into kind of the CI/CD workflows that application teams are implementing on top of Kubernetes.
Yeah, and I would imagine that when it comes to time to market and operational complexity, there's probably a lot to be said for being able to sort of have IT play either an oversight or no role and let developers sort of do their thing as they need to. Was that accurate?
Yeah, exactly. The oversight is key, but the balance everyone's trying to draw is a trade-off between the oversight and introducing friction and slowing down application development, which is ultimately what matters. And so the ability to, for example, let an app team create a policy based on their flows, but then understand whether that policy will automatically be approved by the security team, or whether, no, you need to craft your policy in a different way. Like, those are some of the really interesting workflows on top of the core deep technology that we've built. It's really a fascinating space because you're solving everything from low-level kernel technology problems to really, really interesting high-level organizational workflow problems like the one you just mentioned.
Yeah, it seems like it sort of epitomizes the transformation that's taking place. The IT department of today and the IT department of 1994, when I started working in the space, are rather different. And that's a good thing. And the evolution is accelerating rapidly. Now, if I'm a customer or a potential customer, it looks like you have a community edition and an enterprise edition of Cilium, correct?
Mm-hmm. Yeah. So Cilium's our flagship open source project built, basically implementing all these security capabilities on top of eBPF.
Okay. And what's the difference between the open source and the enterprise edition?
Well, yeah, you've actually kind of touched on it already. So pretty much everything from a core visibility, packet forwarding, security policy enforcement perspective, that's all open source. We really firmly believe that people pick us because we're the absolute best Kubernetes networking and security, and it's open source. When it comes to some of those enterprise workflows on top that we just talked about, right? Like, how do you get this data into your security team SIM like Splunk or Elk?
Right.
Or how do you, work and automate the generation of these security policies and have the security team automatically have approvals and those types of things? Those workflows that are more about different parts of the enterprise working together to solve problems on top of Cilium, that's where we kind of extend with our commercial product, obviously on top of the basics of an enterprise hardened distribution of Cilium.
So if people want to learn more about Cilium, the open source version, the enterprise version, and Isovalent in general, what can they do?
Yeah, so I would, first and foremost, I'd say check out Cilium.io, where you'll find a bunch of getting started guides, really easy to take hands-on, Minikube or any other simple Kubernetes environment, throw Cilium in there, work through some workflows. And then if you're curious about some of those higher level kind of workflows, or your SecOps team is interested in understanding what they can get in their SIEM, check out isovalent.com. A lot of good content there as well.
Dan, thank you very much for this discussion. Really appreciate your time.
Yeah, thanks, Scott. Thanks for having me. I appreciate it.
And thank you to our audience for watching this Spotlight Series segment. If you want to watch more, please visit youtube.com/actualtechmedia. Thank you.